Today we are going to be looking at this. This is on Schneider Euro PC, and I know it looks grim. In fact, it looks grimmer than grim, and good knows how this has been stored upon the time. And I can't see anything else on this that this is an Euro PC, and I think that this means that this is the original version of this. This came in several different versions. And we will be taking a look at this. This machine has been opened. You can see some marks here on the bottom for these clips. Otherwise, you have the floppy drive here. And you have here the room for the ESA expansion slot. I'm not sure how this is loosened. Maybe just try it out like so. We have to look at that. What you can see here on the back is that there probably are game ports in this, and I do think that the Norwegian ones of these was sold with game ports originally in the IO expansion port. You can see that there are some rust here, and you have the serial, you have the printer, you have the mouse. Probably this was a special mouse. You have the monitor, this is CGA something. You have the power, and you have one outlet for hard drive. Probably a proprietary connector that does not mimic anything else. And you have an on-off switch, and this is a physical real switch, not a touch one. And up here you have an external floppy, and this is a 25-pin connector that I don't know anything more about. If it's compatible with someone else's model floppy. I have external floppies from Toshiba and NEC, I think, and some others, and they are all different. If this machine has been stored moist, and this is apparent because of the rust here, there might have been leaking some damaging fluids inside here, and there also is a NICAM battery inside these computers that I have to see if it has leaked. For this computer I have the original power supply, and this is, it's not very heavy, but I do think there is a transformer inside here, and there is also something loose. But this delivers 2.5 amps in 5 volt, 12 volt 0.3 amps I think, yes, and minus 12 volt 0.1 amps. So this is of course replaceable if we know the pinout of the special connector. That is not so very special because it looks rather similar to the ones we know from our beloved Commodore computers. And as I said, in Norway this was sold as a package with gaming ports, and that is because they had this joystick that came along with them. And this I got as part of the deal. And then I have this. It's probably not possible to see this. I will try to change the camera angle a bit. This was all I could manage with the camera. Sorry for that. But this is the original Schneider CM14 monitor, and it do fit the original connector, so I do believe that this is a genuine CGA monitor. And if you look on the back, it says that it's a Farb monitor, it's a Schneider. It doesn't tell us much else. This is probably a rebadged monitor. You have a lot of controls here, and you also have controls here for brightness, contrast and on-off. That's it really for what I got in this package, but I think this was just a nice deal. I have no idea about the working conditions of this computer. I had a friend back in the day that had this computer and bought it in Norway as a new unit. The first thing I will do is start trying to pry this apart and see if we can take a look inside. And as I said, someone has been inside here before. I will try with first taking out this trapdoor conception here and take it from there. And this was not the easy task that it seems to be in the start, and as in many times in life, the answer is just get a bigger screwdriver. Getting stuck in time. Oh, okay, there was this like here, and you have some type numbers here, and here you have the game card, and you do have a screw that's fastening this into the chassis. You can see it's fastening with a plastic screw. And here you can see some corrosion on the copper. EuroPC game card, original. These screws here I think is just for the floppy drive. And you can see they're rusty, these two. And this locking mechanism seems to be quite loose. This one seems to be a bit stuck. So I don't think it will be a very easy feat to get this out. This probably was plastic from a more enlightened area when things like this should not be pried apart by amateurs, or hopefully not at all. There really was no serviceable parts inside of this, I think, because there was no memory expansion options or other things that was sold as loose gadget to this, I think. Yeah, and of course with the danger of repeating myself, it seems like with this computer every problem just needs a bigger screwdriver. And since this is a retro computer from the 80s, we can't just use any old screwdriver. So I have to get to my special retro tools collection. I do have this one from the Norwegian Galo company, and this is a rather more big one. Some of the tools that has been stored in my tool shed has this rust, and I think that's due to a leaking can of solvent I had that was dripping, and I think it dripped on these tools. That's one. That's two. Three. And here the clamps are a bit smaller. This screwdriver does not fit all the way in. And this one was broken. Okay, so that means that we are in. And what do we have here? This seems like a totally original floppy. You can see there is a black bezel hiding inside here. I can see some corrosion here on the main board. This keyboard has an earth connection here. And I do think it's just pried in place like that. Okay, and this just fell out. And here someone has been inside before. I don't know if you can see this, but this connection here is totally scratched by a screwdriver. And you can see this battery has been leaking, and there is extensive damage for this over here. And of course it's not a standard TTL chip, so we do hope we can salvage that. We do also have some corrosion on this one, and this is also a custom chip. The CPU, the 8088, is from Siemens, but they had a license to produce these for Intel, so it stands copyright Intel on this. And you have the BIOS chip, PC character. This is for the graphics adapter. And I don't know if it's a Faraday, but this is part of the chipset. And here you can see a lot of corrosion around here. And this is also a custom part, I think. So let's hope that this is salvageable. I do hope it is, because these PCs are getting rarer and rarer, and probably the leaking battery is what destroys these. So I will just start my work by taking out the mainboard, and I will take out this Varta battery. Let's hope we don't have to label this killed by Varta. And there are some date codes on these things, but I have to investigate a bit further to find what is the newest one. And this computer has 512K RAM. You have two rows here of 256 each. It seems like most of the date codes are 88. This is 88 week 27, week 88 week 28. This is 88 week 30, 88 week 23. So this probably is from the middle of the year in 1988. And it's the A revision. It's that this is a Danish or Norwegian version of this. So before we do anything else, I will try to pry out the motherboard. I do think it's only fastened with these clamps. I can't see any screws here. Just like so. It was only fastened in some gunk somewhere. Oh, this earth line here was screwed down. Let's see if I can take that off in a civilized manner. And that I could. And there is a screw through here and it's soldered in this, and that's okay. On the underside it also is a bit corroded. You can see it on the same places here. So every one of these sockets has to go, and this worst one has to be desoldered too. So I'm going to start with applying some vinegar after I've desoldered this battery first. I first try to desolder it and try afterwards to just cut it if I can't desolder it. It's a handy little board if it's salvageable. There are some components here, diodes in conjunction with the battery, probably no big deal if that goes. Yeah, the solder seems to be meltable, even though sometimes when the solder is corroded it's almost impossible to melt, and that's because the corrosion is messing with the mix-up of the mix of the tin and lead that makes the solder melt quite easily. And one of these metals alone you can't melt with the soldering iron, but when they're mixed together you are able to melt them with this quite low temperature. And when you have this corrosion, the materials is not so good mixed together anymore, and that's why it's much harder to desolder something that's been corroded. Will desocket the chips that we are able to desocket before I do anything else, and that is this one, and this one. You can literally hear the corrosion and the resistance the chip is making when I try to pull it out of the socket. This is an 8088 CPU, and of course that's replaceable. This one here is probably a custom chip. That's the keyboard controller. You can see that it stands next to the keyboard and controls the keyboard. And you can hear the same crustiness here, even though it was only 2 or 3 pins that were visibly corroded. And this is the EEPROM for the character set, and for those of you who saw my Commodore 64 Norwegian video, this is about the same. Back in the day you had to hard code the character set, and this is a Norwegian and Danish character set which has the AO characters for the Nordic language. But this BIOS is probably stock, and it's a V206 BIOS. You can hear that this is less corroded than the other ones, as there is no cracking sound. Yeah. 2 BIOS chips, almost no corrosion on them. You can see beneath the keyboard and in the back here there is corrosion. Yeah, I will just try to wash off this a bit and see how that goes. As this is rather mild vinegar, it's about 7% solution. I just pour it onto the board and distribute it there. There is a lot of corrosion, not large areas everywhere, but there is a lot of vias and almost every one of them are green. Otherwise, the solder mask seems to have kept this in place most of the places, but the keyboard control chip, I do have to desolder this to see if there is anything beneath it, and I'm going to try to do that almost straight away. There is a lot of scrubbing left to do on this board, but as I said, I do have to desolder the sockets and the real-time clock chip that's next to the battery and the keyboard controller chip. And why this keyboard controller chip is the one that has got the brunt of the corrosion, I don't know. Probably it's because of some freak metal composition in the legs of that IC, I don't know. And this loose piece of metal here, it looks like a pin of a socket, and when I look closer I see that there is missing one pin in the CPU socket. So even though the socket doesn't look very corroded, it clearly has been hit with something. So that socket needs to go. The back side of the board looks in much better shape than the front, but even here you can see that there is a lot of graying on some of the solder pads, and there is some green, and a lot of the green from the vias is pointing through, so that you can also see that they're green from behind. And I'm using this needle to puncture all those vias so that I can get some vinegar into them to neutralize the damage from the battery. This socket here has all the pins, all the legs, they are bent over before it was soldered in, and it looks like it's on both sides, so I do have to do something with this before I manage to desolder this, and I probably will take the soldering iron and bend up these legs. This is not easy soldering, I can tell you that. The pins are heating up uneven, they take a lot of heat, and they also seems to suck up the rosin from the soldering, so I do think that this is going to be very hard, and I do hope that this is less damaging on the pads than if it had been just a vacuum gun straight on these pads with the bent pins. I'm not looking forward to using the desoldering gun on this one. And then it's time to bring in the big guns, even though I don't have big hopes for this. This is going to be a long day. Maybe every third of these gets a clean hole. There still are some crud, and this leaves me with no choice. Even though I have heated all these pads, first with the soldering iron and then with the desoldering gun, I don't have any other choice than to use the hot air to try to pry this loose, and I hope that it will go with as little heat and in a short time span as possible. But as we have seen, when the acid or the base from the battery has acted on the soldering, it's losing its ability to melt at low temperatures. So the cruds that's stuck inside the holes, it's very difficult to melt. But finally, after increasing the temperature to 450 degrees and applying a bit more force than I really want to, it seems like this is coming loose. It's only a few stubborn pads left, and we try to be as careful as possible with those. But finally the socket is out, and it's with dread I'm thinking that I also have to desolder two ICs that I hope to keep in one piece, and I also have at least one more socket to desolder. The pad seems fairly crusting, so I'm going to give them a wash with vinegar before I wash the whole board. This keyboard controller I need to desolder, and I think it's good to get as much crust as I can out of this before I desolder it. So I will give this an extra washing. And it will also require a good scraping to get all this crud off. It's really crusty. All the pads on the keyboard connector are also really green and crusty, but I do think they will be easier to desolder because they are quite much bigger and they are also easier to trace if I break something. This is bad, that we can say at once. And this is the way that this was plugged into here, and you can see here that there are some pins that are broken, and they are actually in this plastic in here. So I can see at least 4 fingers that's broken here, and I can see 1, 2, 3, 4 inside there. This keyboard connector has to be changed. Probably it's possible to solder in each pin, and I don't think they would have used this kind of connector if they don't use most of the pins. And if we take a look at the keyboard, we see that the cable is broken, and this cable was the one that was meeting us when we took the computer apart, so this was not something we did break. But this is a failure for another day, because we first have to see if we can get the main board working before we try to take on the keyboard. I will go inside and I will clean out this with a proper brush and some soapy and warm water. I'm back with a clean board, and this time I'm going to try to desolder the keyboard controller and the keyboard connector and the real-time clock. And I've soaked those now in good solder flux and see if this helps better than what we tried before with re-soldering some of the pins before we started. And at least here on the keyboard connector, it's easier to desolder. The solder is melting easier, and it's maybe draining the holes a bit better, but this is also larger holes, so it's probably easier to make the heat go through and also to get suction into the hole. Yeah, but it seems like the flux is helping, as it's also easier to desolder around the ICs. Normally when you use the desoldering gun, most of the solder is sucked through the hole, even though it's on the other side of the PCB. Some is left though, but in this case it's a lot left, because it seems like some of the crud, the crystallized solder on the legs, we have to remove manually, or as we did last time with the heat gun. And finally, first the real-time clock, and then the keyboard controller chip gives up and loosens from the PCB. And I don't think we have damaged any traces or pads that wasn't damaged before. I'm not sure if we can get these chips back in the sockets. They look really crusty, and the legs looks like they could break without any force at all. You can see this looks really grimy still, and I will try to clean this off. This is a unique piece for this PC, I think, so I need this to be working to have the keyboard working on this computer. And I've also taken out this socket here for the EPROM. No, this is the character room for the CGA card. And I also have the keyboard connector here that on this side appears to be okay, but sadly there are some broken pins inside here. So this needs to be changed or taken care of. And I don't think this is something that's easy to find. I have cleaned up the board a lot. There still are some green residue left some places. I do think that it will be difficult to get everything of these off, but this is just on empty PCB, it's not traces underneath this, and this is a solder pad. What I will do now, I will try to solder in sockets in every one of these, and I'm going to use open socket, and that means that I will take these sockets here and I will just cut them and use the lists like so over here. And the reason for that is then I'm able to see the traces here, so if there are traces that I need to follow afterwards, it's easy to see beneath the socket. So that's what I will be doing now. I will tin these leads that I have scraped away the solder lacquer, and I'm going to tin that, and I'm going to put sockets in here, and I'm going to solder them back in place. And hopefully then when I've cleaned these ICs, we are ready to make a quick test. And to separate these also, oops, this is not how this used to go. Normally this goes just fine. It's almost broke on me. So normally I just solder them in like so. Okay, this was a socket that was 1 pin too wide. Amateur's hour again. Yeah, and here I see that this needs further explanation. The reason that I'm doing this and cut off the middle part of the sockets is that when you have boards that corroded, and if you need to do troubleshooting on this afterwards, you need to see the traces beneath the sockets, and that's much easier if you remove all the plastic that is between. So that's why I cut these sockets. And another reason is that I don't have sockets wide enough with the round holes. And when it comes to old corroded and ships with bad legs, and maybe you need to solder in some extra legs if you break something on an old ship, then the round sockets are a much better choice than ordinary sockets with single or double swipe, just contacts on the sides. And here I do something that I almost never do. I apply extra rosin on this to help the solder flow better. And this is even though I use my very good solder with rich amount of rosin flux built in, I find it necessary on this board. This corrosion that is here has been heavily cleaned. I've even tinned the parts with normal solder, and still I find it hard to solder on these pads. And a bit older and wiser, I also apply flux on the other side when I take the next socket, because I also need the solder to flow in between the holes and on the top of the sockets to make contacts on the pads that's only connected on the top side of the chip. These round sockets also, you are able to solder them from the top and make some extra contact if you are able to reach the pin from the side of the socket, but that's sometimes difficult, of course. I use a support socket and a screwdriver to help make the socket flush with the boards when I solder, and this is a much easier task than running around and attaching blue tack and other stuff, and this will be firmly and evenly pressed to the board by the weight of the board itself. On this socket where I applied rosin on both sides of the socket and PCB before I placed it into the holes, I find it much easier to solder. But even here there are some parts of the solder that seems to be difficult to make the solder flow properly on. So I have soldered and I have placed these ICs in the socket, and with this one that was not very easy. The legs here is very corroded, there's still some green on them, but I have not been able to scrape them much because they nearly corroded off several of them. And the same on this side, and I have scraped between them so I'm sure that there is no short circuit, and I'm going to test to see if I'm able to get this to work. Since this is a unique keyboard controller for this computer, this is one of the most important pieces on the whole motherboard, so we can't risk that going bad. But this was also very corroded. I do also have some green left up here, but I don't think there are any short circuit. So I do think that I'm ready to make a first test on this. If we can't get life in this motherboard, we have to find out what component is bad and if it is replaceable. So now I'm going to tidy up a bit on the desk, and I'm going to do a test on the monitor to see if that fires up. And here you must pay attention, this is not something you see often, this is me tidying up before I placing the monitor on the table. It's a heavy rain today. I'm going to connect the power here now. And nothing yet. Okay, there it blinks to life, I can hear and feel the high power. I see nothing on the screen, but it comes to life and it might not do anything until we plug something in here. So I'm just going to turn it off and raise my attention to the power supply. The power supply did have some loose parts, so I'm going to just open it to see inside before I try to switch it on. I'm not sure for how many years it is since last time this was powered on. It seems like there is only these two screws over here, and there are some clips here. Oh, this is very rusty and very dirty. What was in loose inside here is some glue. This has probably been fastening. Yeah, you can see there is more of this glue here. These capacitors don't look bulged. Nothing, I think. Oh, what's that? Is that a capacitor? I'm not sure what that is. There is one component here looking rather glum down here. The fuse looks to be okay. I'm going to try to turn it on. There is no refa caps, so it won't blow up on us, I think. I hope. So I'm just going to put the lid back on so we have a bit of leeway here. I'm not sure what to expect where on this, but I can of course connect this to a plug and do some measurements on this before we plug it in. Let's do that. I'm not sure if it is a coincidence, but this plug is actually the same as a Commodore 64 power plug with all the pins connected. So I'm going to put it on one of these just to make it easier to measure without short-circuiting anything. And I try to use a measurement lead with hooks so it's easier to see. I'm going to use this multimeter here, put it on voltage. I'm not sure if we are able to see this in the camera. That we have to check. We use blue for common and red for the plus lead. I'm going to try to connect this and see if it bangs on us. There is no power on off switch on the power supply. There it is connected. We put the ground first to the common rail. And I tried all possible combinations until I ran out of options. And nothing. So this power supply, it's dead. That's for sure. So I have to to do some measurements, and I did conclude that the fuse was okay by looking at it. I disconnected the mains. Here I'm going to measure the fuse with the continuity tester. Yeah, and the fuse is bad. Or my meter is bad, of course. But I'm going to take out this fuse. And that the fuse is broken is not a good sign, of course. This fuse, it's a slow blowing 315 milliamps. I will try to replace it with about a similar one, so I will be back with a new fuse. When it comes to fuses and old power supplies, of course this was a slow blowing fuse. If this has been a fast blowing fuse, I would have changed it without second thoughts, because these capacitors and stuff that has not been working for a very long time, they might have a higher draw current when you first switch it on than a new component that's in daily use. But this was a slow blowing fuse, and I did think it was okay, but I judged that only by looking at the wire. And the wire looks okay, but on the fuse you can see that there is some black spot on the glass, and I might have overlooked that. Kinds, and I also have the 315 milliamp variant in a slow blowing variant. So I will just confirm that this box is sorted right. Yes, this is the right fuse. We're still disconnected from the mains. And this was a good gripping connector, so I'm going to try this again, like so. Connect to the mains. Going to try to measure again DC voltage. First with a reference to the ground shield. And nothing. Okay, here I had something. Here I measured 23 volt DC, and that should be, if you measured from the minus to the plus 12 volt, so that actually means something. So that means that this up here, actually is the plus 12 volt, and this is the minus 12 volt. And this was the same, so this one and this one was the same, and this one was the same, this one was the same, this one was the same, was the same. So everything with reference to this is 23 volts. I'm very happy that we measured this before we try to turn anything on. This is something we have to look into, and I will turn this off. There is nothing marked anywhere on this power supply, but I might be able to figure it out what's what if I take it out of this box. It seems to me like there is the screws on top of the transformer and one screw here on the printed circuit board, and we might be able to lift this out of the box that's living in. Transformer looks a bit rusty, but that should not matter at all, as long as the copper windings is not damaged. It was making the sound earlier. There has been some repair work on this before, I think. At least it seems like this, and this is a 7812 that this has been changed. We have a 7912, so we do know where the 12 volt and the minus 12 volt should be. That means that this one over here probably is the 5 volt. Yeah, so this should be the plus 12 volt, this should be the minus 12 volt, the yellow one, the green one, I don't know. The black one should be ground, yes, and the red ones should be 5 volt, and the white one appears to be ground. Okay, then we have something to check out. I'm going to change the camera angle again, and we're going to focus on getting some decent voltages out of this power supply. Yeah, this is still unplugged. This is actually the day after, and I've been doing some thinking, and I really hope that there is no short circuit here that means that 25 or 24 volt has gone straight into the Schneider Euro PC, because then it's toast. Every one of the logic chip will be fried with that kind of voltage. But I will try to go a bit more into detail to see what's happening here and see what I can find out about this power supply. So I will start by measuring out some of the basics in here. Start by taking out some grime, I think. so that this is measurable. It's 2 rectifier diodes down here. And we have a Drossel 2 times 5 millihenry, a noise suppression Drossel probably, and you have the X capacitor on the intake also to suppress noise. We do have 2 rectifier diodes, and that might mean that we have a center tapping and only 2. We do have to have some more rectifying than this, I think, because if this is the case, so that means that what we get out of this is actually 1 winding. You have the ground plane connected there, and you have 1 winding here. So there is only 2 windings on this, and they're center connected. And that means that we have our plus here. So if we measure out of from the diodes here, you should have this as a common plus plane, and this should be ground. Maybe I put some tape over the primary side, so I'm not tempted to put my hands on that. Since I had some output, I don't need to measure here on the primary side. And this way, even if I put my hands on this, it won't get toasted. And then let's plug it in and see what we have. Yeah, we have the 24 volt DC out of the rectifier. And this was the 7805, so that means here you should have 12 volt from that ground plane, actually. Isn't that so? Yeah, so there is some seriously things wrong here. I do have to inspect this a bit further and see if I maybe can look up a schematic for this. This power supply is a strange hybrid, because it seems to me like the 7812 and the 7912 is coupled as linear regulators, and that the 5 volt is being provided by a switching regulator. And of course that makes sense, because you have the highest current draw on the 5 volt, the others was just a couple of milliamps. That means that there is a short somewhere here, but I do have to investigate that further, because if the 7812 and the 7912 are directly coupled to the 24 volt winding, they should have power, and also the transformer is giving its output, so it's not drawn to 0 and the fuse is not blown. So I do have to reverse engineer this somewhat and see what's connected where. Yeah, I see no obvious fault, so I'm going to start a more methodical approach. What is happening is that we have one transistor here that seems to be turning off the 12 volt. You're not getting 12 volt before you get 5 volt on the output. That's probably wise. So if that's correct, then it's a wild goose chase to check the 7912 and 7812, because the output to those will be turned off by the transistor that's in front of them. So I will be concentrating on this. I will now try to connect the scope to see if the filtering capacitors is working like they should. If there are some ripple with almost no current, I know for sure that they are bad. But just to make the measuring simpler, I'm going to solder a wire to the ground plane that I can connect to the ground connector on my scope and on my multimeter. Just like so. It will make it a bit simpler to only measure with one hand. I get a steady 24 volt about on this. So the switching regulator is not starting, and that might be a wild goose chase that too, because maybe this needs a load on the 5 volt to start up. I can certainly give it a load. I can find something that I can connect to the 5 volt, and I have identified that this is the 5 volt output. So I will connect something that draws power from here to here. And here I can reuse my C64 power supply tester. Just connecting to the load from just over here, I think will do the trick. And now I have soldered in a load straight over the 5 volt, but I do have some worries here, because when I was identifying the outputs here, I know that this is ground, I know that this is 5 volt, I know that this is the output from the 12 volt, and I do know that the yellow one here is the output for the minus 12 volt. But I do have one green wire that goes from here that might be a kind of a power good signal. I'm not sure about that. It's connected to the same transistor that is making the 12 volt turn on and off. This green one here, that can be the thing that turns the power supply on and off. So here I have to be a bit more investigative and try to find out what's wrong. Maybe we're on a good chase, maybe the power supply is totally fine. I just have to find out what's happening on the main board on this green wire here. And to find out that, I disconnect the power and I put this in continuity tester mode, because I need to find out what pin this green wire is connected to. Follow that up on the main board. So this is a bit fiddly, but I will try to make the best of it. This is the green one. And of course everything is connected to the green one. But how many ohms? This is capacitor charging, so not direct contact. Okay, it is this one down here, like so. Safe to plug this in now, because it's not connected to the mains. And I will do the same again. I will just... So is this one. And it goes over here to the power switch. What we can actually see here is that this line here, this thin line here, goes here, and it goes straight to the switch into this via, and it goes to both parts of the switch. I have to see what it connects to. Let's see if there goes something else to this power switch. It does. But this power switch seems to me to be just like an impulse switch. This is the off position, I think. I can't see no other leads leading from this middle one, but of course there has to be. Okay, I think the middle one here is maybe connected to ground. Yeah, so what this switch actually does when it turns on the power supply is that it connects this green wire to ground, and we can just try that, not directly, but I can do that via a 100 ohm resistor or something and just see what happens. This should be 50 ohms, I think that will be good enough. The power is disconnected, and I just loop this from the ground here. This was not ground, this was the green, and you have ground here. I wonder what happens now when we turn this on. Oh, I will disconnect this, of course, before I connect the mains. And the mains goes in. Voltage 12 volt, minus 12 volt, and 5 volt. 5.3, a little high, but this is with the C64 load. So our power supply is actually working. I will just desolder all the things I've done with it here, turn it around, and we will try our next step to feed the computer with it. So this was a wild goose chase. The power supply was actually working totally fine, but it's better safe than sorry when it comes to these things, as there is nothing worse than connecting a bad power supply and destroying all the electronics with it. After giving the power supply a good healthy dose of compressed air from my compressor, where I de-dusted everything I could, I'm putting this back together again, and this is really just a gnab-gib to put it all together again. So there it is, good as new and newly washed and de-dustified. As you can see, we have not given the monitor the same treatment. It's still dusty and dirty as it was, and we are just going to try to connect it to the motherboard now to see if anything works. We know from before that the high voltage circuit on the monitor is working, but we have not tried it with any picture source yet. Like that, and this is the CGA connector. I give this a bit of a spray with some cleaner. Plug into there. This one is our power supply. This is off. This is plugged in, and turn on the monitor, like so, it's green, and power on. And I do have some sound. Is that memory test tick sound? I have taped over the buzzer when I was washing this. If it's memory sound, it should stop any moment, I think. So I will just check to see if I have 5 volt. Check just over this TTL chip, and I do. After turning the computer off and on again, the memory test tick sound, if it was even that, has disappeared. And it might have been a memory test tick sound, it might have been something that stuck on post-diagnosis. In my next installment I will try this with a diagnostic card, and I will try the CGA monitor with another CGA source to see if it's even capable of displaying anything, so we know that we are fault finding with the right parameters. Hope you enjoyed this video. Please hit like and subscribe if you want to be notified when we post new stuff. It will really help out the channel a great deal. So thanks for watching, and hope to see you in my next one.